This says the table above gives the distance s of t in miles that a car's travel at various times t in hours during the 6-hour trip. The graph of the function s is increasing and concave up. Okay, based on the information, which of the following could be the velocity of the car in miles per hour at time t equals 3? All right, so this is probably important, right? The fact that s is increasing and concave up. Increasing, we can tell from the values. The fact that it's concave up, we need to understand what that means. Why don't I so let's just like sort of sketch like the moment we care about here, like right in this section here, right? This doesn't even have to be like a perfectly accurate graph, but like let's say we know that at time 2, we have time 2, time 3, and time 4, right? So at time 2, it's 55 miles. At time 3, it's like 92. And then I need to make this not look linear. And then at time 4, it's 150. So let's try to make that like a little bit. Okay. So we can't build a tangent line. We don't have we don't have a derivative. If it's increasing and concave up, it could it's going to be bending like that. So I roughly concave up there. And so so what does that mean? Well, if I find a an average velocity, that would be like that secant line, right? And if I find this average velocity, that would be that secant line. So what I'll do is I'm going to find two average velocities, right? I'm going to find the average velocity between those 2 points. That's the slope of that black line. And then I'm going to find the average velocity between those 2 points, all in my attempt at saying something about the tangent line, which is what I want, or I want to approximate that. So I want the slope there. If you notice though, whatever the secant line from 2 to 3, again, I should make it a little more extreme, but like the secant line from 2 to 3, right, is less steep than that tangent line, but then the secant line from 3 to 4 is more steep. So what we're going to do is we'll get two slopes, and then we'll just look for the answer choice where it's in between. So why don't I call this, I'm going to call this like M1, I'm going to call this M2, and what we want here is, we'll say a V of 3, right? And so what we know is that like V of 3 is in between, right? That value has to be bigger than M1, that slope, but it's not as big as M2. Okay, and so M1 is just the secant line, so it's 92 minus 55 over 1. Okay, and M2 would be 150 minus 92 over 1. Okay, so 92 minus 55 is, let's see, 42 minus 5 would be 37. And 150 minus 92 is 58. So we should find an answer choice where the value is between 37 and 58. And the only option there is B, okay? So the concavity is kind of key because it can't be, you notice C is 58 and A is 37. It can't be those, right? We have a strictly between. We have a strict inequality here. So the answer choice B is the only logical one. The problem is probably tricky if you're not shown it, actually. I would say if you're a student watching this for the first time, this is just sort of modeling the intent of this question and the logic that you can bring to it. So if you didn't think of this, that's okay. Just maybe it'll occur to you in the future.